Welcome to Base Power Exponent. This is just a really short clip to kind of help solidify and practice on base power exponents. We all know that an exponent is just a shorthand notation for something that is repeated in multiplication. So when the same number is a factor of a number several times, an exponent is used in the product. What am I talking about? Well, really quickly, let's look at 2 times 2 times 2 times 2, and what the hey, times 2. So here I have 5 2's multiplied to each other. Well, if I'm going to write them as an exponent, then I'm going to write the number 2 because that's what's being multiplied. And since it's been multiplied 5 times, I'm going to make a superscript of 5. So the 2 you see here is what we call the base, and the 5 is what we call the exponent. So that just tells me that 2 to the power of 5 is the base power exponent. And we know 2 times 2 is equal to 4, times 2 is equal to 8, times 2 is equal to 16, times 2 is equal to 32. So what I want you to do is on your calculator, we're going to calculate this out. But before you can do this, you need to know where the caret key is. So pause the video for a moment and find the caret key on your calculator. And once you find the caret key on your calculator, go ahead and press play and come back. All right, so this is 2 times 2 times 2 times 2 times 2. So you are going to put your base number of 2, because that's what we're multiplying. Then you're going to press your caret key. And then you're going to go back and put the number 5. Once again, you have your base and you have your exponent. Okay? So 2 caret key 5 should equal the number 32. Go ahead and try it and see if it works. If it didn't work, then write your question down, and hopefully by the time I finish, you'll have a better understanding. Your question will be answered. Otherwise, this is a good question for you to go ahead and post in the discussion board office hours. See if we can make that a little bit more clear for you. Okay? All right, let's do some examples, because, examples make perfect. All right, so we know this is called the exponential notation, which is the exponent 5 that told how many the base 2 is a factor in multiplying it. So if I was writing it, remember I told you any number, let's use 5, to the 0 power is going to be equal to 1. That means any number. That means 20 to the 0 is equal to 1. 30 to the 0 is equal to 1. And then I also told you any number to the first power is equal to whatever the base is. Well, our base is 5, so 5 to the first power is equal to 5. Now, here's a little thing that you may or may not know. We generally just don't write that 1 at all, because 5 to the first is equal to 5 to the first, right? But in math, we usually just don't write this at all, because any number that exists has to be to the first power. That's like, do you write x to the first power when you're in math? No, you don't write x to the first power. Nobody writes x to the first power. We just know it as x. So you have actually been writing the shortcut for the exponent or base exponent all your lives. Every time you write a number, you've been writing the number actually to the first power. You simply haven't been writing the first power. So that's a little something that should make you feel good about the fact that you've been doing this all along. Okay? Well, let's practice using that caret key to make sure you got a good hang on that. So you're going to put 5 caret key 0, and that should equal 1. If that worked, you've got the hang of it. or you put 5, caret key 1, and that is going to be equal to 5. Again, if you got that answer, you're doing just fine. Now let's talk about rate law and rate expressions. If I have a concentration of a reactant, let's just say A, and it's to the x power, and I know that I have a particular factor at which the rate changes. Let's say the rate changes by a factor of 2, or let's just put it this way. Let's say the rate doubles, okay? Well, I need to look at what I did to my concentration. Okay, so if I find that I doubled my concentration, and I know it becomes a doubling of my rate, then this setup tells me that this is what happens. Let me make that another color. Make it a little bit easier to follow. Here we go. Red is always good. This is what happened to my reactant. When I'm talking about the reactant, that is what my base is. Over here is what happened to my rate. So looking at 2x is equal to 2, I know that my reactant has doubled, and I know that my rate has doubled. So 2 to a power is equal to 2. Well, we already know, by now we should, that 2 to 1 is always going to be equal to itself. So that tells me then that this is 2 to the first power. On my calculator, let's say you have a number and you're not quite sure to what power it happens to be. Let's say that I have, I'll know the number 4 to the x power is going to be equal to 64. Well, you could think in your head that 4 times 4 is equal to 16, so that's not it. And 4 times 4 times 4, we already know that 4 times 4 is 16, times another 4 is going to give you 64. Okay, so that tells me then that this is 4 to the third power. But what if you still having a little bit of difficulty with that? Should you do? Well, that's a little easier. Well, it's easy. It's not like it's a great thing to do, but it is one way to do it, and it does help you one way, and you can always use it to check. So if I have 4 to the x power is equal to 64, then I could put in my calculator 4 caret key 1, which gives me 4. That doesn't match. 4 caret key, got to do a better caret key. 2, that's going to give me 16. That doesn't match. 4 caret key 3, that's going to give me 64. Since this matches, then I now know that that is actually 4 to the third. Okay, that's a long way to do it, and it does take a lot of time. Remember that when you're taking this test, you don't have that kind of time. So I will tell you that when we're doing the rate laws, more than likely you're not going to go past the power of 1. You may have 2 to the first power, you may have 2 to the second, 2 to the third. We may even give you up to 3 to the third. We may go as far as 4 to the third for these purposes. But the more often you're going to run across is just going to be going to the third power. And more often than not, your reactant is just going to double. It can triple, it can quadruple. You will see those. But we're generally not going to go farther than to the third power, if that's of any help to you. Okay? So, to sum it up, We have the base, which is the larger number. In our case, the base is telling us what has happened to the reactant. We have the exponent, which it tells us what has happened to the reactant and how it reflects to the rate, because the rate is going to be whatever this is equal to. So the reactant to whatever that exponent is what happens that reflects the rate that has occurred. Has the rate doubled, then your exponent would be, if it was a base 2, it would go to the first. If it's a base 3 and it's tripled, it goes to the first. If it's tripled itself as a reactant concentration, and let's say the rate is increased by a factor of 9, then that's 3, which is equal to 9. And so we know that that's going to then be x is equal to 3 times 3 is 9. So this is 3 to the second power. Okay, so I hope I've cleared up that a little bit for you, at least enough to get you started. So all the best. Bye-bye.